Hey, AMP class. It was good to see you all today for the review session. Hope you're all preparing and working hard on getting ready for exam 4. We will, I'll be meeting together for that on Friday. So just wanted to say hi before we jumped into these notes on ventilation. So the second set of notes here on the respiratory system, and this is the first material for exam 5. So this stuff on ventilation is not on exam 4, but will be on exam 5. All right, let's jump into it. Okay, so let's, if we were in class, we would start with this preview question, um, and a question of which of these is a completely passive process, meaning that no muscle contraction is needed, and that would be resting expiration. Okay, we'll talk a little bit more about why that is here in a sec. Okay, so how do we breathe? Air is going to flow from an area of higher pressure to an area of lower pressure, okay? And that's just how it works. So we have high pressure in one area, lower pressure in another, then air is going to move from higher to lower pressure, okay? So the way, so really what happens when we change, or when we breathe, we do that by a set of circumstances, which is going to eventually create a lower pressure in our lungs, higher pressure in the atmosphere, so that air moves in. So we do that by these circumstances here. So we breathe by changing the volume in our thoracic cavity, which changes the volume inside of our pleural cavity, which changes the pressure inside the pleural cavity, which changes the volume inside of our lungs, which changes the pressure inside of our lungs. So eventually, we finally change that pressure inside of our lungs. We get that to be lower, right, than the pressure outside, and then pressure is going to go from higher. Air is going to move from high pressure to low pressure. Okay, so a little bit more about how we do that. Number one, we do that with our breathing muscles. Okay, and we've got a lot of breathing muscles here. And really, when we think about breathing muscles, we think about them changing the size of our thoracic cavity, right? Because that goes right back to this. We breathe by changing the volume of our thoracic cavity, okay, which is the same as the size here. Okay, so all these breathing muscles do that in one way or another. And so what I'd like us to think about here for a second is which of these breathing muscles make our thoracic cavity either larger, and which ones make it smaller. Okay, and typically we're going to think about that muscle contracting, but in the case of the diaphragm, I have both contracting and relaxing there. Okay, so just look at the next slide for a second. This shows all of those muscles. So really the two ways to make our thoracic cavity larger would be to raise the ribs up, the whole chest up, or to lower down the floor of the thoracic cavity, which is the diaphragm. Okay, so we can either lower the floor or raise the ceiling, right? To make the thoracic cavity smaller, we could either raise the floor, push the diaphragm up, or lower the ceiling, push the thoracic cavity, rib cage down. Okay, so when we look at these muscles, so the diaphragm, we'll go back to this one here for a sec. With the diaphragm, when it's relaxed, it has this dome shape to it. Okay, so diaphragm, when it's relaxed has a dome shape. When it's contracting, it flattens out. Okay, when it flattens out, that would be the equivalent of moving the floor of the thoracic cavity down. When it relaxes, it pushes back up and increases or moves the floor of the thoracic cavity up. All right, so contracting diaphragm would make the thoracic cavity larger, relaxing diaphragm would make it smaller. Okay, we have external intercostal muscles that are going to be lifting each rib up. When you think of ribs, like when you go to a steakhouse and you order some ribs that meet between the bones of the ribs, that's your intercostal muscles. Okay, that's the muscles that we eat. Okay, so external intercostal muscles lift the ribs up, so those make the rib cavity larger. Pectoralis minor muscle, We can see it right here. Pectoralis minor is right here. That one elevates the ribs as well. So that one's going to be larger. Sternocleidomastoid, let's look at that one. This one as well. Lifts up on the sternum and the clavicle, so lifts up as well, so it's going to be larger. Scalene muscles, let's look at those. Scalenes are right there next to the sternocleidomastoid, do the same thing, lifting up. Okay, so larger. Internal intercostals, these ones we see over here, those ones are going to push the rib cage down. Okay, so those ones make it smaller. And then lastly, the abdominal muscles are all shown here, right? And those are all pulling down on the rib cage, pulling it down. So those make it smaller. Okay, so the ones that make it smaller are going to be our, in this one here, going to be our muscles for expiration. And then the ones that make it larger are muscles for inspiration. Okay, so what is passive and what is active? This is what gets at the clicker question on the previous slide, which was which of the following was a passive process, meaning no muscle contraction is required, and that is the expiration or breathing out at rest. That is driven by, so resting, let's go back to this slide actually, back to the clicker question. That clicker question, resting expiration is driven by the diaphragm relaxing, okay, and also those external intercostals relaxing. Okay, so that's all it is. They just got to relax. Then the rib cage falls down, diaphragm goes up and pushes air out. Okay. All right. So we contrast that with forced expiration, like when we're exercising or breathing really hard. Then we can contract our abdominals to help push the air out, or we can contract our internal intercostals to help push the air out. Okay. All right, so the diaphragm, what kind of muscle is it? Well, it is a skeletal muscle. Okay, it's a very special skeletal muscle, mainly because it's the most oxidative muscle of any skeletal muscle. That means lots of mitochondria. Okay, so what does the diaphragm do? You can see nicely on this GIF right here. When it contracts, it pulls down. That makes the lungs larger. When it relaxes, it goes up, makes the lungs smaller, right? We can see that a couple things go right through it too. The abdominal aorta goes through it, the esophagus goes through it, and we'll take a look at that in a sec too. Okay, so when we think about this, we have to think about a gas law called Boyle's law. And the definition of that gas law is that when the amount of gas is constant, okay, so we're not letting any gas move in this first example, we're not letting it leave at least, pressure and volume have an inverse relationship. Okay, so that's best shown by this little image here. So we take this little beaker, fill it with a certain amount of air. Okay, it's the same volume of air, or it's the same amount of air, total the same. If we counted these little air particles, it will be the same number on each side. Okay, we have this piston up here that can push down or pull up. Okay, so in this case, when the volume is larger, okay, the pressure, so volume is up, pressure is down. Okay, when we move over to this one from here, we push this down, which makes the volume go down, which increases the frequency that these air particles hit the sides here, hit the walls. Okay, and what that does, that increases pressure. So then that makes pressure go up. Okay, if we move back this direction, where volume goes up, okay, now the air particles hit the walls less frequently, and so pressure goes down. So it's that inverse relationship between pressure and volume. Okay, there's a nice video that shows that, but it shows it pretty much just like I did there. You could Google Boyle's law videos on YouTube, and you'll find all kinds of stuff. Okay, and this is how our lungs work, really. But our lungs have two spaces that we need to think about. We need to think about the space between the diaphragm and the lungs, which is right there, and then we need to think about the space inside the lungs. Okay, and let's take a look at that. So, how does Boyle's law apply to breathing? Well, first of all, let's start with our when we're not breathing, when we're just between breaths. Okay, so the pressure in the lungs is going to be equal to the pressure in the atmosphere, so we get no flow of air. Okay, so when we look at this, we see atmospheric pressure being the same as intrapulmonary, or pressure in the lungs. Okay, so no air movement. Okay, but then we move on to inspiration. Okay, so then you want to fill in which muscles are those inspiratory muscles. So definitely the diaphragm, external, intercostals, and then all those other muscles that you can look back on that other slide to see that those ones we use more during forced breathing. Okay, so the change in volume that's going to occur here. So when that diaphragm contracts, it's going to pull down here. Okay, and what's that going to do to the lung volume? It's going to increase the lung volume, right? And that's the first step. So when it increases the lung volume, according to Boyle's law, that's going to change the pressure too, right? So it's going to, if volume goes up, then pressure must go down. Okay, so now we see a decrease in pressure, and so we can look at our pressures over here. Atmospheric pressure is still 760, but now we have a lower pressure in the lungs, right? So air is going to move from high pressure to low pressure, so air is going to flow into the lungs. Right, and that's really the point of those inspiratory muscles, is to increase volume so we decrease pressure. Okay, expiration is just the opposite. So we relax the diaphragm. Okay, we relax the external intercostals. Right, and then by doing that, the diaphragm moves up. Thoracic or rib cage moves down, so we decrease the volume in the lungs. And by Boyle's law, we know that decrease in the volume causes an increase in pressure, and so pressure is going to be higher now in the lungs than it is in the atmosphere. So pressure is going to move the air from high to low, so it's going to move out of the lungs. And that's really what breathing is all about. Okay. And so definitely just want to understand those steps and how that applies to Boyle's law, and which muscles are actively or passively contributing to this, both during resting inspiration and expiration, and forced inspiration and expiration. Okay, so a couple factors that are related to ventilation that affect ventilation. Number one is called lung compliance, and the definition of this is it's the lung's ability to stretch and expand. Okay, so when we take a deep breath, we stretch our lungs out, right? That's compliance, just how stretchy is it. It's not how much it bounces back yet, but it's just purely how much can we stretch it out. And we see it with asthma. We see a bronchiole that's constricted because of all this inflammation around the tube, right? So instead of it being able to stretch out nicely when we fill it with air, you can see it's kind of bulging here. It's tight, so we can't stretch it out as much. So lung compliance is decreased by asthma. Okay, so what's the cause of an asthma attack? It's a high sensitivity to a certain allergen that inflames the bronchioles, causes constriction. Okay, just like we were just talking about with the immune system. Okay. Other causes will be pollution, secondhand smoke, and it makes it hard to get a breath in. Why is that? Because we can't stretch it out, right? We've lost compliance. It's hard to breathe in because of that loss of compliance. Okay, we also increase compliance, we decrease compliance with obesity and pregnancy, and that's literally just because there's something heavy sitting on top of the thoracic cavity that has to be lifted when you take a deep breath in. either that extra fatty tissue or the baby. Right? So it's a weight on top of the thoracic cavity. Decreased by chronic bronchitis. This leads to excessive mucus and smaller bronchioles. Decreased by lung cancer, or if your alveoli collapse, like in a collapsed lung, those all lead to decreased compliance. Okay, what about elasticity? Okay, so this is kind of the other side of that. So we have the compliance, which is how much can we stretch it out. But then the other side of that is once it does get stretched out, how well does it bounce back? That's the rebound part. That's the elasticity part. Okay, so emphysema drastically reduces the elasticity of the lungs. Okay, and this happens. Emphysema is caused by the alveolar walls breaking down. Okay, each of those little tiny sacs that we see over here on the right, if these internal walls break down, then we end up with these larger sacs, right? Much larger sacs are there instead of those little individual ones. And it's harder to get these walls to get close to each other to push the air out. If we just have these little tiny walls, then we can flatten those down, push the air out. But those bigger walls, it's hard to do that. And so the lung elasticity breaks down and we can't push air out. So it becomes very hard to push air out. So we're thinking of the thoracic volumes you looked at in your lab, or you will look at in your lab if you haven't done that yet. And we're looking at, for the last bit of information on exam 4, this drastically increases RV, or residual volume. Okay, this causes breathing to be more energetically costly. We have to work hard to breathe. Breathing takes 15 to 20% of our energy instead of just 5. Okay, it takes so much energy. People have this look to them like that, where they're constantly contracting these muscles, and they end up with something called a barrel chest, which is kind of an expanded thoracic cavity because of those muscles there. Okay, this also leads to damage to the pulmonary capillaries, which leads to high blood pressure, which leads to heart failure. And obviously this messes with our gas exchange. So this is caused directly by smoking, as well as a genetic component to this. Okay, another factor affecting ventilation, which I just touched on briefly when we talked about the lung anatomy, is surface tension. Okay, and surface tension is really the idea of water sticking to itself via those hydrogen bonds. Okay, in your lungs, those little tiny alveoli are so small that, as I drew on the previous slide, those water molecules, the bonds between those water molecules can actually span the gap from one wall of the alveoli to the other. So we need something to break apart those hydrogen bonds between the water molecules. We need something to act like a detergent, which breaks those water molecules apart, and that is surfactant. And this chemical is only produced in the last 2 months of pregnancy. And so babies that are born like this little guy here, tiny little preemie babies, they're not making surfactant yet, or they're not making enough. So they need to be on a ventilator like this, which is forcing their alveoli open and helping them breathe, because their lungs are collapsing without that help. This is one of the reasons that babies breathe while they're in the womb. Even though they're fully in water, they suck water into their lungs as part of the development process, and that stimulates the production of surfactant. Okay, so this is a great image of this surfactant, showing these water molecules binding to each other, pulling the alveoli in. Okay, when surfactant literally just gets in between those water molecules, breaks those hydrogen bonds, allows the alveoli to open up. All right, guys, and that's all we got. So hope you study this hard, and we'll see you guys soon.